this question, I'm just putting the entire question under here so that you guys can see it, okay? So this says the relative housing cost for U.S. city is defined to be the ratio of the average housing cost for the city over the national average housing cost. So that's considered the relative housing cost, how you find that for a city in the United States. So it's going to be expressed as a percent. Okay, now if you look at this graph, and in order to get this correct, you have to be able to understand the graph, which is going to be the tricky part on the SAT because many of you guys get confused when you look at a graph. But just take it easy, take a deep breath, you can do it. Okay, so at the bottom, this is the population density, and this is the relative housing cost. Okay, also known as the percent of national average cost. So if you look at this, you see that population density, like when the city is really small, or if it's just a town, okay, think of a small little town, the housing cost is not as expensive, right? And doesn't that kind of go with our common sense? Because we live in a metropolis like Los Angeles where there's tons of people, and how do you think our housing prices are going to be then? Very expensive, right? So you guys see how that kind of goes like this, right? Anyway, it says here, a scatter plot above shows the relative housing cost and the population density for several large cities in the large cities in the year 2005. The line of best fit is also shown and has the equation y equals 0.0125x plus 61, which is basically y equals mx plus b, this being our slope, right? And x plus 61. Which of the following best explains how the number 61 in the equation relates to the scatter plot? Okay, so they want to know, so we obviously know that this portion right here is going to be the actual slope, but they want to know, what does this number 61 here mean? Okay, so you have to go through the options, okay? And you have to understand in this situation with m, this right here is, it could be changing, like, sorry, this x right here. If x will be most likely the population density, right? If you see here, this is the population density that is on the x line. If the population density is at 0, that's going to negate this. What will y equal then? 61. So do you guys see that 61 will always be there, even when the population density is at 0? So again, how I did that was, if you were to plug in, I'll make this bigger, y equals 0.0125 x. This number right here is what we're looking at. And x equals, down here, this equals the population density. You could have it at 0 right here. If it's at 0, look at where y is. Do you guys see where that is? It's at 61. So we know that it's 61% will still always be there. Therefore, what you have to do is eliminate all of the different things that have nothing to do with that. So look at A. In 2005, the lowest housing cost in the United States was about $61 per month. Is that what they're saying? No. Remember, this is in percents. Okay? Yes. Thank you. And I just want to check that these are in there too. And then if you look at B, in 2005, the lowest housing cost in the United States was about 61% of the highest cost. Is that what we're talking about? No, it's not of the highest cost, it's 61%, okay? C, in 2005, even in cities with low population densities, housing costs were never below 61% of the national average. Again, not that either, okay? D, in 2005, even cities with low population densities, like 0, housing costs were likely at least 61% of the national average. That is exactly what we're talking about. Therefore, D is the answer.